Good morning, everyone. Hopefully, you're watching this and enjoying a nice remote day. Wanted to go through a couple examples of working with specifically interior angles in a triangle, but some exterior as well. Sometimes they can get a little bit complicated in terms of the problem solving and things. So I'm going to go through a few examples. It's not an exhaustive list. There's certainly going to be some problems that you try that might be a little bit tougher. You do have the answer keys to these worksheets posted in Google Classroom under the 12.3 answer keys. I know the worksheets will say 12.4, but I just scan them all together. Take some time to look over those as well. Hopefully that helps, and we'll check in with class next time to make sure you're all doing okay. All right, so this is the homework day 1, 12.4. Again, the answer keys to all of these are in the 12.3 answer keys, but I just scanned those all together. I'm going to move that up so I have a little more space. So the idea is when we have an interior angle, okay, it's equal to half the sum of the intercepted arcs. So this arc here and this arc here. What I want you to notice in this particular problem, though, is that I don't know what the measure of these arcs is. And while I get a couple of ways that I can do that, what I want to show you is that the way around it is to simply give this angle a variable. Because if I can find this angle, I can just subtract from 180 degrees to get x. Not the only way of doing this problem, but the one that I think will stand out the most. Because y is equal to 1/2 the sum of the intercepted arcs. And so 62 degrees, 170 degrees. And when I add those together, I get 1/2 of 62 plus 170 is 232, and half of that is 116 degrees. I wanted to use y there because I really need to know that that's not what I'm solving for in the end. I need to know what x is. But here I have this linear pair of angles that have to add up to 180 degrees. So x equals 180 minus 116, which is going to be 64 degrees. Okay. Now, the other way of doing that, and I'll show you that here right now, I know that a whole circle has 360 degrees. So 360 minus 170 minus 62 is 128 degrees. That's what's left over for this arc and this arc. I don't need to know specifically what each of them are, because I know that when I add those together, it has to be the leftovers. And so I can say that x equals half of the 128 because it's equal to half of the sum of these two arcs, which have to add up to 128 degrees because those others add up to the larger value. Well, half of 128 is 64, and you'll see that matches up with what we got the other way. So a couple of options there for how you want to approach it. It's up to you, and there might be other ways, but I wanted to at least show you those couple. I also wanted to show you number 3 here, and the reason I wanted to bring up number 3 is just because sometimes it throws people off when the x is on the arc and not in the angle. But I really want to stress to you that the statement, the interior angle is half of the intercepted arcs, of the sum of the intercepted arcs. We can just translate that. The interior angle, well, that's 90 degrees, is equal to half of becomes multiply. The sum, well, that's addition, of the intercepted arcs. Well, that's x and 40. And so it doesn't matter that the variable's in a different place. That's what I really want to stress to you. As long as you know the rule. The interior angle is equal to half of the sum of the intercepted arcs. Okay. So 90, well, let's actually not do that. I'm going to multiply by 2 to get rid of the half. That's going to get me 180 equals x plus 40. Rather than distribute the half and deal with a fraction later on, let's just get rid of the fraction right away. So all I did here was multiply the entire thing by 2. Okay? But that does not multiply here because it gets used up multiplying by the half. All I have to do here is subtract 40, 140 equals x. Okay. So again, slightly different type of problem, nothing major, just wanted to point that out. I'm actually just going to scroll or shoot right down here to number 6 because this is the other problem that I really wanted to point out. Again, a lot of these problems have some different problem solving things going on. I'm just trying to show you a few to help you understand what's going on. The exterior angle, remember, is equal to half of the difference of the intercepted arcs. And right here, those are not going to be congruent marks. I want you to understand that one arc is x, that's right here. The other arc is down here. Together, though, those arcs make up the whole circle. So even though I don't know what this arc is, I know that it has to be 360 minus x. Because whatever the entire circle is, that's 360, I'm going to subtract the x from this top arc, okay, and I'm going to get this bottom arc. So if x was 100, I do 360 minus 100 to get the bottom. If x was 200, 360 minus 200 to get the bottom arc. So it's just following the algebraic pattern. And like we did up in number 3, we're going to follow our rule here. So the exterior angle, 35, is equal to half of the difference of the intercepted arcs. And I'm always going to take the bigger arc minus the smaller here. So bigger arc is going to be x minus 360 minus x. And I know that's going to get a little funky with a couple of parentheses there. Nothing that you can't handle. Okay, you just have to take some time. Remember that algebra that you learned last year. So I'm going to multiply by 2 to get rid of this fraction. That's going to get me to 70 equals x minus 360 minus x. And so that's a way that we can get rid of one set of the parentheses by getting rid of that fraction. What you have to remember is your distributive property. So I'm going to distribute that negative to the 360 and to the negative x, because really that's a negative 1 times right there. We just don't write it. And so what I'm going to end up with is 70 equals x minus 360. And negative times negative becomes positive x, like that. The beauty of that is that now we have like terms. 70 equals 2x minus 360. The x plus the x, give me the 2x. Okay. And there it's just algebra. Well, it was all algebra before that, but it's still just algebra. 70 plus 360 is going to be 430 equals 2x. Okay. And I know I'm running out of space a little bit, but dividing that by 2 gets me 215 degrees equals x. If I wanted to find that smaller arc, then I would just do 360 minus 215, which is going to be 145. I don't need to do that, but if it helps me check out to make sure things make sense. And so again, following that pattern of exterior angles, exterior angle is half of the difference of the intercepted arcs. It's just that we didn't know what the arcs were specifically, so we use x for the whole thing and 360 minus x for the leftovers for the bottom arc. Okay. Check these out. You're going to try some other of these problems, and then we'll do a little bit of review in class and go over those. Remember, you do have the answer keys here. They're under the 12.3 answer key in that PDF. So you can check these out. You're going to be graded on completion, so even if you just take the answer keys, make sure that you know what you're doing, that's fine. But we'll check in class next time. Have a great day.